Welcome everyone. Today we're going to learn about Lesson 8.1b, Factoring and Solving. We are going to continue our adventures of reviewing Algebra 1 together. So the first thing that we're going to look at here is multiplying two binomials. Multiplying two binomials requires the FOIL technique. It is essentially the distributive property. So what we have here are two binomials where we have two terms here and two terms there, right? So when I have two binomials, we have these two terms being separated by an operator. Either it's going to be a plus or a minus, it doesn't matter. As long as we have one of those operators there, you have a binomial, okay? So this is our first binomial, and it's going to get multiplied by another binomial. So when we multiply two binomials, we are going to FOIL. And that's just an acronym that we use to multiply. So the F means first. I'm going to multiply the X and the X here. So that's our first. And now what we're going to do is we're going to move on to the outer. So we're going to take that first term and multiply that by this second term in the second binomial here. So that's outer. And then our inner is just the second term in the first binomial being multiplied by the first term in the second binomial. So this is the inner. And then lastly, you're going to multiply the second term in the first binomial with the second term in the second binomial. Okay? And that's just a lot of words that's going on. But if we do examples here, I think it's going to make some sense. All right? So let's go ahead and multiply. Our first example here deals with x minus 7 times x plus 8. So we have two binomials. So we're going to go ahead and multiply the x and the x. That's our first. So first, x times x, that's x squared. And then we're going to go ahead and multiply the x and the positive 8. That's our outer or outside. So x times positive 8, that's positive 8x or plus 8x. And then we need to be very, very careful. This is negative 7, right? Minus 7 or negative 7, same thing. We're going to take that and multiply that with this x. That's going to be our inner. So negative 7 times x is negative 7x. And then lastly, we're going to multiply the negative 7 and the positive 8, okay? And that's going to be negative 56. So now what we're going to do here is this. We are going to combine the like terms. Okay, we're going to combine the like terms so that we can have our final answer. So x squared, and since these two terms here are alike, they have the same variable, and the exponents, of course, are the same. We can combine them. So how many x's do we have left? 8x minus 7x, that's going to be just 1x, or you can say x. And then lastly, this negative 56, our constant, you can't combine that with anything else. This is the only constant that we have here. So that's going to be part of our answer, and we're done. Let's look at number 2. We have a minus 11, the quantity squared. So here's the thing. We know for sure if I give you 4, the quantity squared, you just rewrite that 2 times, right? You're going to multiply 4 and 4. And of course, that's going to be 16. If I give you negative 4, the quantity squared, negative 4 times negative 4, right? So what is that going to give me? 16. So basically what I'm trying to say here is you have this, it's being squared, you write it twice. So we're going to do the same thing for a minus 11, the quantity squared. So we're going to rewrite that. We're going to write this 2 times. And since we have two binomials, we're going to FOIL. So first, so that's going to be a times a, that's a squared. Outer, a times negative 11, that's negative 11a. Inner, negative 11 times a, that's negative 11a. And then last, that's negative 11 times negative 11. So that's plus 121 or positive 121. And again, we have to combine these two terms here. So a squared, negative 11a minus negative 11a, you're starting negative and tacking on more negatives. So we have negative 22a. And then we're going to go ahead and throw in that positive 121. Okay, so this is our answer for number 2. Number 3, we have two binomials, so we're going to multiply. First, outer, inner, last. So first, 3w times 5w, 3 times 5, that's 15. But the w and the w are being multiplied with that, so w times w is w squared. Then we're going to go ahead and multiply the 3w and the 8, so that's going to be 24w. Then we have the inside, 6 times 5w, that's 30w, plus 30w here. And then 6 times 8 is 48. Okay, so now we're going to go ahead and combine these two terms. So your answer is 15w squared plus 54w plus 48. And there you have it. Okay, so that's essentially multiplying two binomials FOIL. Okay, so now we're going to go ahead and get into the territory of factoring. So here we basically use the distributive property. Now what we're going to do is learn how to undo the distributive property. That's what factoring is. It's the process of undoing the distributive property. Okay, and here are two techniques. One is the difference of two squares, and the second one is factor by the greatest common factor, or factoring by the GCF. So if you have a perfect square minus a perfect square, then you can rewrite that as a plus b times a minus b. So once you take the square root of that perfect square, whatever the result is will be your a value. And then you're going to go ahead and take the square root of this other perfect square, and whatever the result of that will be your b value. And as you can see, this binomial, of course we have the a and the b here, we have a plus sign, and as we look at the other binomial, of course the a and b are there, we have a minus sign. So when you have the difference of two squares, if you have a perfect squared minus a perfect square, it's going to give you the a plus b times a minus b. Okay? And then now what we're going to do is we're going to look at this, the factoring by the greatest common factor. So you have the a, b plus b, c. Notice that a, b are being multiplied here, and it creates this one term. And you have this bc here. B and the c are being multiplied, and it creates another term. So ab plus bc, if I look at these two terms, what do they have in common? They both have a b. So what we're going to do is we're going to extract the b out, and the b is going to go outside, and then we have the parentheses, and the a and the c will be inside of the parentheses. Okay, we're going to do some examples so things make sense. So the first thing that we're going to do is look at number 4, 25x squared minus 49y squared. I need to think, is this me needing to use the greatest common factor? Do I need to factor by the greatest common factor, or do I need to factor using the difference of two squares? Now, here's the thing. There's that minus sign, so maybe I should consider difference of two squares? I don't know, but I think it's best if we look at the 25x squared and the 49y squared. And the reason being is these could be perfect squares. And if you're unsure if they are perfect squares, this is what I need you to do. I need you to grab your calculator, input or press the second button, then the x squared button, and type 25. Is square root of 25 a perfect square? Yes, right? It gives me an output of a whole number, right? So the square root of 25 gives me 5. So I can definitely confirm that 25 is a perfect square. We can go ahead and do the same thing for 49. It gives me a whole number. So yes, 49 is a perfect square. And x squared, y squared, y'all, it's in the name, perfect square. So we can safely say that those are perfect squares. All right, so what we're going to go ahead and do is we're going to create our answer. So I'm going to go ahead and draw 2 sets of parentheses, just like that. One of the sets is going to have a plus sign, and the other is going to have a minus sign. When I took the square root of 25, that's going to be 5, right? So 5 is going to serve as our little a's here. So I'm going to put 5 and 5. But I don't want to forget about this x squared here. If I take the square root of x squared, then you're going to get x, right? So I can't forget to put an x here and an x there. I can't. And then we have the plus and the minus. That's wonderful. So now what we're going to do is we're going to look at this. So here's 49. I'm going to go ahead and take the square root of 49, which I already did. That's 7. So 7 is going to serve as our b terms here. So 7, 7. And then just like taking the square root of x squared, if I were to take the square root of y squared, of course, that's going to be y. So I put a y here and a y there. And this is now our factored answer. This is what I expect. If you have a difference of 2 squares just like this, your answer should look something similar to this. We're going to do the same thing for 5. Is 36 a perfect square? Is 121 a perfect square? Do we have a minus sign involved? Because remember, difference just means subtracting. So it's basically our little minus sign. So if all of those things are met, right? This is a perfect square, this is a perfect square, and we have a minus sign. We are going to factor using the difference of 2 squares. So we're going to go ahead and put those 2 sets of parentheses there. 1 plus, 1 minus. The square root of 36 is 6, and the square root of 121 is 11. So I'm going to go ahead and put 6 here, 6 there, 11 here, 11 there. And don't forget the x squared and the y squared. So if I were to take the square root of x squared, you got to put an x here, and you got to put an x there. And you're going to have to put, since I'm taking the square root of y squared, here's a y, there's a y. That's your answer. Okay? All right, number 6. No minus sign involved. So you're not using difference of 2 squares. But perhaps you're going to factor by the GCF. Okay? So let's look. 5x squared plus 25x. What we're going to go ahead and do is I'm going to look at these 2 terms here, right? The term before the plus sign and the term after the plus sign. If I look at these 2 numbers and also the variables, okay, what goes into 5x squared and 25x at the same time? Now, what I mean by the what, I need the highest number and or variable that will go into these 2 terms. Not the smallest. I don't want the smallest. I want the highest. I know if I'm looking at these 2 terms here. So first of all, what I'm going to do is this. This is where I'm going to put the GCF. That's where I'm going to put the GCF. And of course, this is where the parentheses will be positioned, okay? So the greatest common factor. Again, what is the highest thing that goes into 5x squared and 25x at the same time? I know for sure that 5 goes into 5, and at the same time, keywords, at the same time, 5 also goes into 25. So that means that 5 is going to go right there. And both of these terms here carry an x. So do I ask myself, okay, since they both carry an x, x can only go into x and x to the second power at the same time. Hey, I just want to go ahead and take a moment to clarify about the x being the GCF, or being part of the GCF. Now, looking at that x squared and x, you know for sure that the smallest exponent is 1 between the two. So we know that those two terms carry an x, so what you need to do is put the lowest exponent there, which is 1. So you have 5x to the first power, or you can just call it 5x, and that's going to be your GCF. I hope that makes sense. So it's going to be 5x, and then I need to go ahead and put stuff here. So 5x times what will give you 5x squared? That's going to be x. Now, do that again. 5x times what this time will give you 25x? It's positive 5. And you're done. You're done. Number 7. Negative 2x squared plus 8. Okay, so here's the thing. Whenever I see a negative right in front, when you have your little GCF here, you're going to factor that out, no matter what. Okay? So you need to make sure that you factor the negative out. Now, looking at the 2x squared and the 8, what is the greatest common factor that goes into 2x squared and 8? I'm thinking 2. 2 goes into 2, but at the same time, 2 also goes into 8. Okay, the greatest common factor, right? So 2. Do I need to put an x here? Let's see. Well, there's an x squared. Is there an x here? No, so you don't put x here for the GCF. There's no x for the 8 here, or, besides the 8 here. So, it doesn't work here. Negative 2 is going to be our GCF. So let's go ahead and put the parentheses right next to the GCF. Negative 2 times what will give you negative 2x squared? That's just going to be x squared, okay? And then negative 2 times what is going to give me positive 8? That's going to be negative 4. So your answer is not negative 2 times x squared minus 4. Okay, but I'm going to go ahead and write this over here. I'm going to rewrite negative 2 times the quantity of x squared minus 4. Because here's the reason why. If we look at this, x squared minus 4, this is a perfect square. And then we have that little minus sign. And 4 is a perfect square as well. So what we need to be careful of, since we took the GCF, we don't just stop there. We need to make sure we look at what we have. Do we need to keep going, or should we stop? In this case, we cannot stop. Negative 2 times the quantity of x squared minus 4, you have a difference of 2 squares that you need to take into consideration. Meaning we need to factor this right away. So what we're going to do is we need to keep the negative 2, right? We need to keep the negative 2, And then we're going to go ahead and write our two sets of parentheses. So we need the a minus b times a plus b, or you can say a plus b times a minus c, right? The plus and the minus, the order doesn't matter as long as you have them somewhere, okay? So if I take the square root of x squared, that's going to be x. So x here, x there, 1 plus, 1 minus. Again, you can put minus here and plus sign there. The order doesn't really matter, but you'll still get the same answer, right? And then if I were to take the square root of 4, that's 2. So you got to put a 2 here and a 2 there, and look at that. Now it's completely factored. We're done. Okay, hopefully that makes sense, and hopefully I'm doing, justice with all kinds of problems that we're dealing with here. Okay, so what we're going to go ahead and do is we're going to look at the backside. We are going to get into the territory of factoring with 3 terms. When we factor with 3 terms, we are going to use this little method called the X method. And we're going to be working with the a value being 1. So this is just a throwback to Algebra 1 again. Factoring, of course, is the process of undoing the distributive property. Now, if you're given a trinomial just means you have 3 terms. And the trinomial is in the form ax squared plus bx plus c. We're going to use the method on the right. Now, this a, this b, and this c, those are my coefficients. Those are my coefficients. Okay? So what we're going to do is this. Before we use the X method, you need to make sure that you look for greatest common factor. Okay? We need to factor by the GCF before we use the X method. And the X method goes like this. You draw a big X, and you're going to put your C term here. You're going to put your C term here, and you're going to put your B term there. And now what you're going to do is you're going to put a multiplication sign and a plus sign. And now you have these 2 things here, factor 1 and factor 2. Factor 1 times factor 2 must give you the C value, but at the same time, factor 1 and factor 2, the 2 numbers that you multiply together that gave you that C, they must add up to B. Okay, so let's go ahead and look at some examples here. If I look at 8, what we need to do is this. We're going to go write our coefficients first off by writing A, B, and C. The A is whatever is in front of the x squared. Now, typically, or not typically, I shouldn't say that. I should say commonly, students would say that A is x squared or x or whatever. I'm talking about a number, an actual number. So when I look for the coefficient in this example, the A term in this case is actually 1. Okay, so the number in front of x squared, since it's invisible, it's going to be 1, right? So I'm going to put 1 here. And now what I'm going to do is I'm going to look at the B term, right? So the B is going to be in front of the x, okay? So what is the B term? You see 13, but is it 13? What actually is in front of 13? Negative 13. So the B value is negative 13, and then the C value is the one without a variable, and that's going to be positive 42. Okay, so I'm looking at these signs when I'm determining my A, B, and C. So C is going to be 42. Okay? All right. So we have 1, 2, 3 terms, and there's no factoring by the GCF. I can tell you that, and we'll get into that where we have to factor by the GCF first and then use the X method. But right now, this is what we're going to be doing. The A is 1. Let's use this method. I'm going to draw an X, and I'm going to think of two numbers that multiply together, right? But at the same time, add together. Okay, and I'm going to start over. Don't worry. What I want to do is our C value is going to go up top, right? That's going to be 42. And our B value is negative 13. Okay, so 42 is our C value, and our B value is negative 13. So you're going to think of two numbers that multiply together that'll give you 42. And at the same time, these two numbers that you picked originally must add up to negative 13. Hopefully that clears everything up on what I'm trying to say. Okay? So, can I think of two numbers here? Let's see. Let's try 6 times 7. Okay? So, if I put 6 times 7 into my calculator, yeah, that's going to give me 42. But if I put 6 plus 7, using those two factors, or potential factors, will it give me negative 13? So if I'm looking right now, 6 plus 7, that's 13. But is it negative 13? No. So what I need to do here is, okay, first of all, these are not the two numbers that I want. I need the two numbers that multiply together will give me 42, but at the same time, add up to negative 13. And this is what I'm going to do. This is going to be crazy. What if I made this 6 a negative 6 and this 7 negative 7? Okay? Okay, so remember, 6 times 7 is 42, and 6 plus 7 is 13. Okay? So these two things, one here, one there, they don't work. So what I'm going to try now is this negative 6 and negative 7. Okay, so we have a negative times a negative. Negative 6 times negative 7, that's positive 42. That's good. That's what we want. So now what I need to do is I need to check and see if those two values, those same values, add up to negative 13. Negative 6 plus negative 7. Look at that. Negative 6 plus negative 7 is negative 13, and that's what we want. So since negative 6 times negative 7 is 42, right? And negative 6 plus negative 7 is negative 13. We can go ahead and put those numbers there. So negative 6 times negative 7. Okay? So now we're going to go ahead and do this. A set of parentheses here and a set of parentheses there. And we're going to go ahead, since we're using the variable x, that's what we're going to put here and there. Okay? So we have negative 6. We have negative 6. So we're going to go ahead and put minus 6 here. And since we have a negative 7, then we're going to go ahead and put minus 7. So we have x minus 6 times x minus 7. This is your answer. We just factored 8. Okay? And I know that was a very, very long explanation, but I wanted to take my time and explain what is going on so you understand at least the basics of factoring a trinomial. Okay? Let's take a look at number 9. So, for 8, our a value, if we look, our a value is 1. Okay? For 9, our a value isn't 1, it's actually 2. And the thing that you always need to check before you do this method is check for the greatest common factor. Okay, so that means, okay, what is the greatest common factor? What number goes into these three terms at the same time? And that number must be the highest number. Not the smallest number, the highest number that goes into 2y squared, negative 8y, and negative 10. Okay? And I'm thinking 2. I'm thinking 2. 2 goes into 2, 2 goes into negative 8, and 2 goes into negative 5. Right? That's the highest number that goes into those three terms there. So now, since this is my GCF, of course we need to put those parentheses. 2 times what is 2y squared? That's y squared. 2 times what is negative 8y? That's negative 4y. And 2 times what will give you negative 10? That's negative 5. Okay? So that's our first step, right? We have this, but if I cover up the 2, we have y squared minus 4y minus 5. It's in this form, that little quadratic we have here. It has that ax squared plus bx plus c, but I know we're dealing with the variable y here. But we're still going to do the same thing. We're going to use the x method. But first off, let's go ahead and figure out our a, b, and c. We don't need this 2 right now. We're going to look at this, but the 2 will be part of our answer, okay? So just hold up. So our a will be the number in front of the y squared, okay? So of course it's going to be 1, right? The invisible 1. That's going to go here. 1. Our b, all right, that's going to be 4 or negative 4. That's right, that's going to be negative 4. And then c is that constant without the variable. So it's not 5, it's negative 5. Okay? So a is 1, b is negative 4, and c is negative 5. So we have those. We figured our a, b, and c. So I'm going to go ahead and draw my x, right? So again, what goes up top? Our c goes up top, right? So negative 5 here and negative 4 down below. Negative 4 down below. So I need you to think of two numbers that multiply together. It'll give me negative 5. And at the same time, add up to negative 4. And I'm going to go ahead and say negative 5 and positive 1. I'm put plus 1, okay, for positive 1. Negative 5 times positive 1, or negative 5 times 1. Let's go ahead and look at my calculator real quick. Negative 5 times 1, that's negative 5, right? That's what we want. And then using those two numbers, those same numbers that we put in the calculator, we're going to add them this time. So negative 5 plus 1, that's negative 4. Is that negative 4? Yes. So those are my factors, right? Those are my factors. So what we're going to go ahead and do is this. Put the two sets of parentheses here and there. And since we're dealing with the variable y, we're going to go ahead and put y and y. Here's negative 5, so minus 5 here. And this is positive or plus 1, right? So plus 1. But we cannot forget, do not forget, this wonderful 2 here. That was in front of this, right? So the 2 needs to be part of the answer. There you go. It's 2 times the quantity of y minus 5 times the quantity of y plus 1. Okay? All right. I think I can go a little faster now. So I'm looking at this thing here. Number 10, we have negative 4z squared minus 52z plus 120. This is not 1, so maybe I need to factor this. I can tell you that the GCF between these three numbers here is -4. That's your GCF. And don't forget, there's a negative right at the beginning, so you need to factor that out. So negative and then 4. Go ahead and put the parentheses. -4 times z squared will give you this. -4 times positive 13z will give you -52z. And -4 times -30 will give you positive 120. So our A, B, and C is this. So A is 1. Not -4, by the way. It's 1. B is 13. And C is -30. Draw my little X. Our C term is -30, so it's going to go up top. And 13 will go down below. Okay, that's our B. Two numbers that multiply together will give me -30, but at the same time add up to 13. So X plus, and I'm going to say 15 and -2, right? 15 times -2 is -30, but if I were to add these two numbers, that'll give me 13. So the variable is Z. So Z plus 15 times, oops, I actually need that, Z, there you go, minus 2, right? Here's positive 15, and here's -2, right? So we have Z plus 15 times Z minus 2, and don't forget, we have the -4 there, okay? So that's going to be part of our answer. And go ahead and rewrite that over here so you can see. So what was it? -4 times the quantity of Z plus 15 times Z minus 2. Okay? All right. Now, we learned how to factor. We are going to solve by factoring this time. So here are the steps, and you've done this before in Algebra 1. Step 1, move everything to one side of the equation to make one side equal to 0. So if we look over here to the right, x squared plus 5x equals -6. That's not a 0, that's a -6. Move that -6 to the other side. Or what I mean by that is you need to add 6, right? You're going to add 6 on both sides here. So you can make this right-hand side of the equal sign 0, just like this one. All right, so we have x squared plus 5x plus 6 equals 0. Factor the polynomial. It just means, polynomial just means many terms, using the methods discussed earlier. So we talked about GCF, we talked about difference of two squares, and then X method, right? So I'm looking at this. You're going to go ahead, for this example, you're going to factor, but since we have 3 terms, you're going to use the X method, okay? And then, this one's the little weird part. You're going to use the zero product property, which means you take that. Okay, so after you did the X method, you got X plus 3 and X plus 2, okay? So you're going to take this thing and equal that to 0, just like what we have here. And you're going to take this other thing and you're going to set it equal to 0, just like this. So once you solve, so X plus 3 equals 0, of course, when you solve for X for that case, it's X equals -3. And then when you have X plus 2 equals 0, you're going to solve for X for this one. X is -2. So you have 2 X values, which will be your answer, okay? That's step 4, solving for X. So let's look at 11. R squared minus 15R plus 54 equals 0. The best thing about this problem is that the right hand is already 0. And if we look at the left-hand side, we have 3 terms. Do I need to factor by the GCF here? No, there is not a greatest common factor for these 3 terms here. So what we're going to go ahead and do, we don't need to do step 1, but we can go ahead, and since we have 3 terms, use the X method. So I think we know our A, B's, and C's. The C value is going to be 54. It's positive 54. And then the B value is -15, right? So the two numbers that multiply together, that'll give me 54, and add to negative 15 is going to be negative 6, and it's going to be negative 9. Okay, so negative 6 times negative 9 is 54, and negative 6 plus negative 9, you're adding two negatives here, so you're going to get negative 15. The variable is r, so r minus 6 times r minus 9. And don't forget this. Don't forget that. Equals 0. Equals 0. Okay? So, what happened here? X plus 3 times x plus 2 equals 0. X plus 3, set it equal to 0. X plus 2, set it equal to 0. And I'll explain the concept later, but right now what we're going to do is we're going to take this, r minus 6 equals 0, and we're going to take that, r minus 9 equals 0, and we're going to solve. So r equals 6 and r equals 9. Those are your answers. R is 6, R is 9. Okay, so two R values. Now, the zero product property, remember, when we have equations, we need the specific variable that will make the equation true. We want to make sure that the left-hand side agrees with the right-hand side. So, essentially, if I put R is 6, right, if I plug that in, right, this is going to be 6 minus 6 times 6 minus 9. Now, that 6 minus 6, that's 0, right? This part here is 0, and 0 times anything will be what? 0. So this left-hand side is 0, and the right-hand side is also 0. That R value here, this R value here will make this equation true. The left-hand side will equal to the right-hand side. But it's not just R equals 6. It can also be R equals 9, right? Because if I were to plug in R with 9 minus 9 here, that's 0. And then 9 minus 6, that's 3. Again, 0 times anything will just be 0. So this left-hand side of the equal sign is 0, and then the right-hand side is 0. So these two R values will make this equation true. That's the zero product property. Number 12, 2x squared plus 4x equals 16. Looking at the right-hand side, is it 0? No, this here is 16. I need to move this away. So in order for this to be 0, I need to subtract both sides by 16. So you have 2x squared plus 4x. Be careful. I know I put a minus 16 under the 4x, but these are not the same, or I should say, they are not like terms. 4x minus 16, right? And look, what is this right-hand side supposed to be? 16 minus 16 equals 0. Okay, look, 2x squared plus 4x minus 16. We have 1, 2, 3 terms. And what do I need to do? Look, GCF, right? Always look for the greatest common factor, aka the GCF, before factoring using the X method. And that's what we're going to go ahead and do. What is the highest number that goes into 2, 4, and negative 16 at the same time? 2. So 2 is going to go outside. And then 2 times what is x squared? X squared. 2 times what is going to be 4x? That's positive 2x. 2 times what is going to give me negative 16? That's negative 8 equals 0. Now, I'm going to go ahead and do this. I'm going to highlight the x squared plus 2x minus 8. That's my trinomial. That is what I'm going to factor, right? So here's my x. A, B, and C. C is negative 8. B is positive 2. And then the two numbers will be 4 and negative 2. 4 times negative 2 is negative 8, and 4 plus negative 2 is 2. So 2 times x plus 4, right? Plus 4 times x minus 2 equals 0. Oh boy, I'm going to need some room here. Let's see. let's move this all the way up over here. Okay? So, we factored, but that's not the end result, if that makes sense. Our goal here is to solve for x, right? So you're going to go ahead and set the x plus 4 equals 0. And then we're going to have the x minus 2 equals 0. Okay? And then obviously 2 is not equal to 0 whatsoever. So you don't need to worry about this at all. That 2 that you see right there, don't worry about that. We're trying to figure out the x value that will make the equation true, or x values that will make the equation true. Okay? So x plus 4 equals 0. If you solve for x, that's x equals negative 4. X minus 2 equals 0. If you solve for x, that's going to be x equals 2. And again, that 2 not being 0, you don't put x equals 2 again. Or if this was like a 4 in front of a parentheses, 4 is not 0. You don't say x equals 4 or x equals negative 4. That has nothing to do with it. Just don't worry about this, okay? So these are your two answers. That's all I'm trying to say. All right, number 13, 9c squared equals 64. Okay, this one's interesting. 9c squared equals 64. I want to make sure that the right-hand side is 0. So let's go ahead and do that. Minus 64 minus 64. So 9c squared minus 64 equals 0. Okay, and look, 9 is a perfect square, c squared is a perfect square, 64 is a perfect square, and look, these two terms are separated by a minus sign. So we have a difference of 2 squares. So this is what I'm going to do. It's going to be 3c minus 8, right? So if I take the square root of 9, that's 3. If I take the square root of 64, that's 8. And then if I take the square root of c squared, of course, that's going to be c. So 3c minus 8. And then this other one's going to be 3c plus 8 equals 0. Now, you're not done. This is not what's expected of you. But yes, it is expected of you. But what I'm trying to say is you're solving, right? If you have an equal something, you are solving for x. So take this, set it equal to 0. So 3c minus 8 equals 0. So 3c equals 8. C equals 8/3, right? So that's our first answer. The other thing is you take this, 3c plus 8. You're going to set that equal to 0. So 3c equals negative 8, and then c is negative 8/3. That's your other answer. And look at that. I'm just, infiltrating the number 16 here. But these are your two answers. It's part of 13. All right. So c is positive 8/3 and c is negative 8/3. Y'all, what you can do is you can just write it like this. C is plus or minus 8/3. It's the same thing, just all in one. Okay. All right. Number 14, x squared equals negative 7x minus 10. We're going to go ahead and move everything to the other side. So x squared plus 7x plus 10, what? Equals 0. Then I'm going to go ahead and draw my little x. C goes up top. 7 goes down below. 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. So x plus 5 times x plus 2 equals 0. So just based on solving this, I don't want to write x plus 5 equals 0. I can just see it, right? X is equal to negative 5 and x equals negative 2. Okay? So those are your answers. And one thing I see from students is that when they have x plus 5, x plus 2, they immediately think that x is equal to 5 and x is equal to 2. But this one's positive, this one's positive. What you're doing right now is when you're giving me the x value or what x equals to, just switch the sign, if that makes sense. So if this is x plus 5, then your answer should be x equals -5. If this is x plus 2, right, then your answer should be x equals -2. And don't forget to box the whole thing. 15, 3y squared minus 100 equals 2y squared. All right, once I subtract the 2y squared, where does that go? Do I do 3y squared minus 100 minus 2y squared, or do I subtract it from here? Well, I think I should subtract it from the 3y squared because they are like terms, right? They are like terms. So the right-hand side is 0. 3y squared minus 2y squared, that's y squared, and then this negative 100 or minus 100 goes right there, right? All right, we have a difference of perfect squares equals 0. So y plus 10, y minus 10 equals 0, y equals -10, y equals 10, yes? Or you can just say y equals plus or minus 10. There you go. Okay, right? We have a positive version of 10 and a negative version of 10. So y equals positive minus 10, or plus or minus 10. Okay? All right, let's look at this one here. 2x squared minus 8 equals 0. Hey, this is the editor again. I just want to point this out before I say anything else. As you can see, we have 2x squared minus 8. The 2x squared isn't a perfect square, and neither is the 8. So what's going to happen here is we're not going to use the difference of two squares. We're actually going to factor this by the GCF. The 0 is there on the right-hand side. We have 2x squared minus 8. This, I want to go ahead and factor by the GCF. So the highest number that goes into 2x squared and negative 8 at the same time is 2. So 2 times x squared minus 4 equals 0. But this here is a difference of two squares. So really, you got to do 2 times x plus 2 times x minus 2 equals 0, right? And then again, this 2, when we're solving, you don't need this because 2 is not 0, so it doesn't matter. Take this x plus 2, equal that as 0, so x equals -2. And then here, x minus 2 equals 0, x equals 2. So your answer is x equals plus or minus 2.